Buongiorno e benvenuti al nostro appuntamento, alla nostra Digital Breakfast, come ormai abbiamo ribattezzato questo appuntamento mattutino che vede oggi ospite Giuseppe Desogus, Università di Cagliari, esperto e docente Giuseppe, posso dire efficientamento energetico,
Sì,
senso ampio.
se riesci a tradurlo, sì.
Se riesco a tradurlo, energy efficiency in the building.
In buildings, yes.
In building.
Fondamentale in buildings.
Hi, man. Good morning. Welcome.
Good morning.
So we continue in English. So, right. Hi, man. Welcome to Giuseppe Desogus for our digital breakfast. So I leave immediately the floor to Giuseppe to start with his presentation. And so thank you to be with us.
Thank you.
And please.
Okay. Thank you very much, Luigi. And firstly, I must apologize with all the students because my English at the moment is a bit, how can I say, out of practice, because it's been a long time since I had my last lesson in English. So I need more practice, but you know, at the moment with being locked down at home, it's not easy to practice speaking nor in Italian nor in English. So just forgive me for my errors. I think that the mistakes I will make will be a lot, but if anyone needs more explanation or needs clarification, please ask, and I will give you both in English for English speakers or in Italian if someone does not understand my poor English. Okay, that I start sharing my screen now. That should be this one. Okay. Does anybody see my screen? Please let me know if there are some any problems. I would like to have the chat, but I don't know how it can work.
It works. It works.
It works. Okay. I can see the chat. So
just to start the presentation.
Okay. Okay. Here it is. Very good. Participant. Okay. Let's put it here. Okay. Okay. So the title of my presentation is Policies and Tools for the Energy Efficiency of Buildings. When I decided this title in agreement with Luigi, it was more or less 1 month ago. In the meanwhile, European Commission published a very interesting and important document that is called Wave Strategies for Renovations, that maybe some of you already know. And so I decided to use the scheme of this document that, in my opinion, is from some point of view even very important, even revolutionary, and to use the scheme of this document and try to put on the table some issues, some concept regarding energy efficiency of buildings at the moment, which is the current situation of European building stock, and which has the perspective and the probable future policies to try to implement and improve energy efficiency in the European buildings. So the summary of the presentation is this. Let me discuss just a bit about the nickname of this document. If you want, I can share maybe just very quickly the document, so to let you understand what I'm talking about. That is this one. This document is being drafted in half of October. It's very recent, and I think that it's designing new strategies for building renovation that, as I said before, are quite interesting and for some aspect revolutionary. And you can find it on the European website, or if you want, I can share you. I can ask the secretary to share the document with you. And just let me discuss just a moment about the nickname, a renovation wave for Europe. The terms wave, in my opinion, is very interesting because it's something about the fact that at the moment building stock is like a quiet pond of water. And I think that no one so far have ever tried to throw a stone in this pond, and didn't manage to shock in a certain way, to shake this this quiet situation. And as we will see in the next slides, at the moment the European building stock is quite how can I say, it's very quiet. It's always the same. It's very difficult to implement strategies for its renovation and changing. So the term wave, in my opinion, is quite correct. The summary of the presentation. So we will see the current scenario, so the current state of art of European building stock. We see the key principles of the future strategies that the European Commission is trying to implement. And we will see the main points to be developed toward a faster and deeper renovation of buildings. And we will try to draft some very quick conclusions. So the arguments, the discussion is very important, and the issues on the floor are a lot. So discussing them in just 1 hour is not very easy. But however, I'll try to give you at least some hints and some to summarize which are the most important aspects. So current scenario, as maybe I think that everybody knows already that European buildings are the most consuming sector of energy in the Union. The building sector is responsible of about 40% of energy consumption, of the overall energy consumptions. If you take into account that we have at least 2 other important sectors that are transport and industry, you understand that the weight of buildings is very, very important. 40% of energy consumption means more than 30% of greenhouse gas emissions. It means that there is a small improvement between energy consumption and the equivalent greenhouse production. It means that the energy we consume in buildings is not so, how can I say, dirty. It's not so. It's a bit clean. There is a. We start to see improving percentage of renewable, but the goal of the European Union in 2050 is to reach zero emission of building. So from building, so it's a very challenging perspective. In this picture, that is the source is BPIE, that is a think tank of German think tank that works with the European Commission and has a lot of interesting documents. I suggest you to see their site. And we see what we see. We see the percentage of buildings by age. We nowadays know very well that the reason why buildings consume a lot of energy is mainly due to the fact that they are old. It's not a fault of the buildings themselves. We cannot blame the buildings to be old. They were constructed at the moment of their construction according to the rules that were enforced at the moment. So it's not a mistake in a certain way. The point, as we can see the following, is that we have now a few instruments to improve and to accelerate the renovation of this building stock. If you think that, for example, the first European EPBD, the European Building Performance Directive, EBPD, dates back to 2002. It's about here, more or less, around here. So it means that all these building stock, all this part of building stock was built before European directive. In the meantime, starting from the oldest building, a bit improvement on building technology was implemented because the technologies very slowly improved. For example, when we discovered in a certain way that the steel or the concrete frames, building walls were enlightened, were lighted, were more light, and have been better insulated compared to the load-bearing masonry that was used before the Second World War. So some technological improvements were already used. However, it is only more or less at this point that some regulation became compulsory, we were obliged, we as designer or constructor, so on, were obliged to follow. In Italy, we know that the first law, the first important law is in 1990. That is more or less in this period, but as we maybe know, it was unapplied for the most part, was not implemented. So we waited. We start to work better when we had the European directives. That means that the energy performance of building is quite poor. If we can see here above the energy level of the building stock, and it is the energy performance indicator. So it is the kilowatt per square meter per year consumed on average by each building. And we can see that more than half of the buildings are in the lowest classes and have a consumption of about 400, more than 400 kilowatt per square meter per year. It's a huge amount of energy, even if we can see in the following, it is not, it does not correspond to the real consumption of buildings. Nowadays, we are able to construct buildings that can consume 70 or even less kilowatt per square meter per year. So if you compare these two values, it is evident that we have a huge improvement if only we will be able to convert all the existing building to the current standard. It's not easy. European Commission is trying to increment, to rise up the annual renovation rate up to 3%. It's at the moment we are about around 1%. It seems a very low increment, but if you think that in 30 years, so to 2050, it means the renovation of 90% of building stock. It's a quite challenging goal. The reason why this renovation rate is so slow are a lot, and we will see some of them in the following. It must be said now that working on buildings is very difficult because compared to working in other sectors. For example, if we think of the improvement that have been in car market, it is evident that in few years, few decades, we passed to very polluting and consuming car to more efficient car, and now to zero emission car, if we take into account the electric car. So, but it is an industrial world that, and these industrial schemes that are not easy to replicate on buildings sector. Another, can I say, terrific data is that of this 1% of yearly renovation works, only the 5%, so the 5% of 1%, very, very small percentage, is deal with deep energy renovations. Another fact that is emerging, that we are working on buildings in a very, let's say, light way. We're not able to implement strong renovation interventions, deep renovation interventions that are the most effective. Let me just give you a quick classification on how we work on the buildings at the moment regarding renovation works. The first step is what I call crypto technologies, from Greek. Crypto means hidden. There is a large share of the market that is occupied by technologies that make their, can I say, invisibility a point of strength. So there is the tendency that it's unluckily supported also by some designers to work to try to implement energy performance without to improve energy performance without working on the morphological aspect of the buildings. So there is a tendency to maintain the building as it is and pretend or try to apply technologies that try to improve energy efficiency without modifying the building. It is not possible. It is a share of the market that is generally occupied by the most ineffective technologies. I reported on this. I I put on this slide just an image of one of these products that is a paint that is said to be insulating paints. So the try is to reduce the thermal loss through the walls just by painting the walls. Nowadays we know it doesn't work, but in the past recent years, these technologies were strongly supported by the market, and can I say it's a very dangerous way of thinking, and I think we have to get rid of these strategies and of these technologies. The second and more at the moment is the more frequent step of intervention is the substitution or integration of single components. So, for example, we can work, the most frequent, as we see in Italy, for example, as we see in the following, is the substitution of windows. Window substitution is quite easy, and it's effective, but it's not a global intervention. It cannot improve their overall efficiency of the buildings. Other possible solutions are insulating the floors. So, for example, attic floors, as in these pictures, or substituting components, parts of HVAC systems, so substituting boilers, heaters, and so on. It is the second step, not so performing, but it's at the moment the most pursued in Italy, but also at the European level. A third step is very interesting. It is quite innovative and deals with addictive strategies. So the strategies is the one to add a second or a third skin to the buildings that can improve in an important way the energy performance of the building. These addictions can create new spaces, can create bioclimatic, can host bioclimatic strategies, can host also renewable energies devices or efficient energy systems. There are some research at the moment at European level for these strategies. I think they will be quite promising in the future. The last evident step is demolition and reconstruction. It is the most, I can say, drastic, but it is evidently the most effective. It's not easy to implement such a strategy. This picture is taken near my home in Cagliari, and it represents the substitution of old buildings. We should discuss about the conservative issues regarding demolition of historical buildings, but we will skip it for the moment. And we can see as these old buildings are substituted by new buildings that have very different energy performance. These interventions have a lot of limitations. One regards the preservation of historical heritage, which is evident. The other one is that we have to find buildings that have only one owner, because, and we will see it in the next slides of the presentation, when we have co-owned buildings, everything becomes more difficult. So in terms of energy savings, energy efficiency, which are the differences of all these, among all of these steps? Well, light renovation, for example, component substitution, can achieve maximum 20–30% energy reduction. So it's a important step, but not so so evident, because deep renovation, that means addictive or demolition and reconstruction, can achieve 70–80% of energy reduction compared to the current status of the buildings. So it is evident that the European Commission is trying to push on this kind of intervention. So addictive, for example, or demolition and reconstruction, or substitution, but of a lot part of building, of nearly whole building components. So trying to reach these goals, which are the key principles in this new document of European Commission? Well, the most important is the first, energy efficiency first. Only produce the energy we need. We know that working only to energy production, it's easier. Working on renewable energies, it's easier than working on energy efficiency of final uses, but it is not sufficient. It is nowadays demonstrated that it's not possible to supply the actual energy consumption only with efficient production technologies, for example, renewable. So we have to work on the consumption, on the efficiency of final uses, in this case of buildings. It is the most difficult things to do, but we cannot skip it. Affordability. Sustainable buildings widely available. At the moment, let me say in a very easy way that performing buildings are for rich people. Saving energy is a luxury at the moment. It's something that only who have money can afford, because efficient building costs more than poor performing building. It is evident. We can work on reducing the cost and the difference of cost between traditional technologies and innovative technologies, but they cost more. It is also a question of the cost distributed in the future, in the lifespan of the building. So we have to work on the global cost of the building, and who can afford more investment at the moment will benefit of lower expenditure in the future. So we have to try to make this possibility available to most of the population. Then we have decarbonization and integration of renewables. Okay, but it's only the third step. Life cycle thinking and circularity. Building can be seen as carbon sink. Yes, yes. So we can store carbon in building, and we can reduce the carbon footprint of buildings using sustainable technologies and life cycle technology. So technology can be easily reused and recycled and so on. High health and environment standards. It is another fundamental aspect, in my opinion, because when we talk about energy efficiency, we very often forget to understand how this energy is used in the buildings. A building can use a lot of energy or few energy, but it is important that this amount of energy is used to reach comfort condition within the buildings. If this is not achieved, this is not guaranteed, it's not possible to talk about energy efficiency. We will see it in the next slide. green and digital transition together. So nowadays, digitalization is everywhere. In most of European or policies papers, the word digitalization is always present. But in renovation of building sector of buildings, it assumes a very peculiar meaning, and is digitalization, in my opinion, has two fundamental collocation regarding knowledge of the building and regarding management of the building. We will see it in the next slide, the following. And finally, respect for aesthetics and architecture quality. And I had also social, for example, quality of buildings. So buildings are not only energy machines. We cannot consider them anymore just consumer or producer of energy. It's not possible. It brings aware. We have to understand that within the buildings, we have to work within some strict boundaries, because buildings are places where people live, and it makes everything more and more complicated. We will see when we discuss about some other issue in the following presentation. 20 minutes. Okay, and so. Let me see regarding faster and deeper renovation. So just have a quick look at the current scenario in Italy. We have said that global renovation interventions are very rare, and it's true. For example, let's see the comparison between the investment in building refurbishment in general and energy renovation interventions. As we can see, only a very small percentage of investment in building sectors, and particularly on renovation, is addressed to energy improvement of energy performance. So it must be can I say it must be, it's something that is need to be correct. Among all the intervention that are financed by public funding scheme, and we will see something in the following. Which are the most pursued intervention? Well, global renovation are these very small line at the bottom of the bars. We even can see it. Then we have envelope insulation and window substitution, that is this part of the bars. Then solar thermal and HVAC renovations. It seems to be good that envelope insulation window substitution is so important, but we'll see that here we are. The most part are windows substitution. So most of the public funding that Italian government invested on private building energy efficiency just regards only window substitution in terms of single interventions and also in terms of money invested. We can see opaque wall insulation, this is roof and slabs insulation, this part of the bars. This one is window substitution. Then we have solar thermal and HVAC. These data are extracted from the annual report that Enea, that is the national Italian National Energy Agency, every year published. if we analyze according to the same data, the energy saving in terms of tons equivalent of petrol, we can see that the most financed, that are windows, are also the less performing. So funding schemes are not well addressed. Italy is spending money in mainly substituting private building windows. It gives a contribution to energy efficiency, but it's not the best, the optimized scenario. So it is important to implement strategies that can take into account which are at the end the overall effect of this of the financial incentives. Another issue that is important to consider when we talk about buildings can be resumed by this statement of Lord-Kelvin. Lord-Kelvin is one of the father of classical thermodynamics. He said, if you cannot measure it, you cannot improve it. And the question that I ask is always, are we sure that we are able to measure buildings? Do we really know our buildings? The answer that according to my experience, give most of the time is no. We have, and we cannot really understand two things of buildings, in my opinion. Two categories of information is difficult to. The first that seems to be very basic, but believe me, it's not it's not easy to have access to this kind of information, is how the building is built. We really don't know the technologies implemented, used to build a building, especially a private building. Public buildings can be better known, but existing private buildings are very difficult to, for example, to identify very simply which kind of walls, which kind of materials used for walls, slabs, roofs, and so on have been used, because most of the time we have not a design. The design is a very general, basic design that is only needed to verify that the building is respectful of urban legislation. But the choice of material is something that maybe designers and constructors decided on building site and building construction site, and this knowledge is lost forever. We only can try to detect it now, when the building maybe has 30, 40 or 50 years old, and we have to use technologies that sometimes are quite invasive. Do not believe that energy labeling solves these problems. Every EU member state define simplified methodology to have the possibility to draft energy, to make energy certificate, to be able to draft a certificate, but sometimes the methodologies are quite simplified. What does it mean? It means that energy I'm sorry, can you give me just a moment? Just few moment. What do you want? Going out? Go. Please forgive me, but working at home means some familiar problems, like the dog that needs to go outside. Sorry. Okay, and so I was saying that energy. So energy labels do not represent the real consumption of the building, because they are most of the time made with simplified methods, and moreover, they presume that the building is occupied and is used in standard condition. What does it mean, for example? That we always have a 20-degree temperature indoor during the winter season, and it is not always true. So there is a quite big difference between energy audit and energy labeling. Energy labeling just is used, can be used only to compare different buildings and to try to assess which are their standard consumption. But they're not reliable when we talk about real energy consumption. Energy audit is what we need to do on buildings. And working on big buildings like hospitals, schools, commercial buildings, big public buildings, it is cost effective. But making energy audit on small residential buildings, sometimes only on one flat, it's not cost effective, okay, because it needs very expensive and invasive diagnostic technologies that are not, can I say, compensated by the return of, excuse me. Stai zitta, vieni dentro e stai zitta. Cammina. Okay, maybe she comes down now. Okay, and so energy audit on where it brings to communities, it brings to gathering, it brings to the fact that if we want to improve energy efficiency of widespread private buildings, residential buildings, we have to gather together and try to implement technology, for example, or procedures like energy audit that can be, whose costs can be distributed over a lot of users. The same is about digitalization. That digitalization can help to make energy audits. Digitalization can help to make can help to make reliable energy audits. But for example, BIM procedures, building information modeling procedure, are again expensive. So it is not possible to use them just only for one small home or flat, house or flat. This, for example, is a BIM model of a building in our faculty that is the case study of a project, that is Prelude project. And we're trying to use building information modeling to collect as many as possible information regarding energy performance of building. And it is possible. It is possible to collect data with infrared thermography, with heat flux meter measurements, and also it is possible to connect a sensor, so building automation, with building information modeling of the building. But it cannot be done for a single, again, for a single flat. So it is important to create, as we will say in the following, energy efficiency communities. Give me just 1 second again. I hope this is the last interruption. Okay. Knowledge. Then let's try to find an instrument to improve renovation. Well, renovation has a cost. Sometimes it's quite expensive. How can help people to sustain the cost? Well, the first scheme, the first idea that came up at European level was to implement what is called third-party financing. So involve a third party that is not the owner or the final users of the building, but is someone, a company, maybe a bank, that is interested in investing in energy efficiency. The basic assumption on which third-party financing works is that consumption afterwards are higher than consumption afterwards. So I have a real energy reduction. The return of the investment is very simple. It depends on the difference of consumption, for example, on a yearly basis, multiplied by energy cost. So if I save 100 kilowatt hour per year, and they cost 0.2 euro by kilowatt hour, it's very easy to make the multiplication. But are we sure that this assumption is always true? No. It works only for big buildings. Again, it works only for big consuming buildings, hospital, schools. But in residential building, this assumption, this equation is not always true. Why? When I'm talking about if I have an industrial process that produce, for example, a good some that could be shoes, for example. Well, the goal of my industrial procedure is well known. I have to produce a certain amount of shoes to be on the market. If I want to improve the efficiency of the process, I have, for example, to substitute some machines and use less consuming machines. But the goal is always the same. This kind of shoes, this amount of shoes. On buildings, we use energy for what? We use energy for giving people comfortable condition of life in terms of thermal condition, visual condition, acoustic condition, quality of air, and so on. The first issue is that comfort is subjective. We can talk about comfort only on a statistical way, on a statistical basis. So on a lot of intervention, we can, involving a lot of people, we have the possibility to be statistically sure of comfort improvement, for example. But at single building level, it's not easy to understand if comfort is perceived, because it depends by a few people. And the perception of, for example, thermal condition is different from people to people. And another important aspect is that if comfort is not met before the works, the first result of the works will be reaching comfort condition, won't be consuming less energy. Because if people can afford to have comfort condition, they will tend to spend the same amount of money and that energy, but just to improve their condition. It is good because we're talking about fuel poverty. We're talking about people, low-income people generally, that can afford to heat or cool sufficiently the building. And it's a good thing. But who wants to invest in other people comfort benefits? That's the point. Not private. Public, yes, but not private. So when we talk about third-party financing, and we're talking about maybe energy service companies, take into account that if this procedure, this mechanism is not supplied by public subsidies, it doesn't work. And then we have the necessity of public incentives. Generally, there are two kinds of incentives. They're diffused maybe in more or less in every European country. On bill, that is generally for public bodies. So the government, the state, give cash back to give money back to the public bodies, owner of buildings, that invested on energy efficiency, or on tax that are generally for private owners or tenants. In Italy, for example, on tax scheme are quite, can I say, very discussed at the moment, because in Italy, just starting from a few months ago, we have a new scheme that cover up to 110% of investment. So the state give back more money than the one spent for the works. Why? Because they understood that it is very we need a lot of strength, a lot of strong instrument to implement energy renovation, especially in private residential building, because they are quite a difficult sector on which work on. The on-tax scheme is the most critical. First of all, as we have seen on the slide, the previous slides, incentives are not related to effectiveness of intervention. In Italy, we are spending a lot of money for window substitution, but they're not the most effective. There are some methodologies, and we worked, for example, on operational research methodologies, and for example, linear programming or simplex algorithm, to improve the incentive scenarios. So incentives cannot be given just, cannot be dedicated just to single technologies, but we have to optimize the mixture of technologies that depends, for example, on geographic and climatic condition to reach the best scenarios. We demonstrated, for example, that there can be an increment in energy efficiency compared to the current situation up to 20%, with a reduction of cost that is about up to more or less 5%. So we can spend less money in pushing on those technologies that are most effective, or that this mixture of technologies, these mixed scenarios that are most effective. This is something that public government should do at European member state level. It's not important, but it must be done. The other problem on tax financing is that they're not able to avoid fuel poverty. Low-income people have no money to heat buildings. So they have no money to invest in energy improvement. It is evident. So they must be supplied by the government should find a different way to to address this target of people. And another problem is the diffusion in some EU members, especially Spain and Italy, of co-owned buildings. So block of flats that are divided in many flats, and every owner is owner of what? Is owner of his own building, can I say a first-class property, and then of all the common part of the building that are shared by all the owners. Let me say that it is a B-level property. But this B-level property that people do not consider important are the technological parts that are, can I say, in charge of energy efficiency. Facade, roofs, they are common parts, and they are the most important parts of the envelope in terms of energy efficiency. In Italy, we haven't found so far a solution. Co-owned buildings are very difficult to be managed, and finding agreement among all the owners to work on the common part is very, very difficult. And it's an issue. This is the percentage of co-owned buildings in Italy. It is quite high, and is most concentrated in these periods that are just after the Second World War, where in Italy there was a urgent need of reconstruction that bring to build up a lot of multi-property buildings. So Italy is trying to go beyond the limits imposed by co-owned building, increasing the financed quote of intervention up to 110%. So they're trying to say, if I give you more money than the one you invest, maybe this intervention also on common part became more interesting. And the other possibility is to transfer the own tax credit to a third part. So mixing a third party scheme with a public financed scheme. So I have no money to invest, but I can give my tax credit to a third investor. It's very new. It started a few months ago. We will see if it is a good solution or not. The last issue is that is recalled also in the European document, participatory and neighborhood-based approach, communities. But the European document talks only about energy communities. In my opinion, energy communities are not enough. If energy communities are only producing, selling, and buy energy for a group of people at convenient price, they will not contribute to improve energy efficiency of building, and above all, and this is the first and important issue, to manage and preserve long-term efficiency. What we're still skipping at the moment is the importance of maintenance of buildings. Maintenance of private, small buildings. Big buildings, schools, hospitals, commercial buildings have facility management procedures. So maintenance is easier, but on small or co-owned buildings, maintenance is quite difficult. The solution could be communities. Communities not only in charge of energy production and selling and trading on the market, but also communities able to implement maintenance procedure on renovated buildings. Otherwise, in 30 years, there will be someone like me in 30 years talking about the same thing, talking about the fact that we had efficient building once that were built according to the previous regulation, but now there's no more efficiency. Why? Because the buildings naturally age, decade. It's normal. And high performing buildings are more subjective at aging than low performing buildings. Heat pumps, for example, need more maintenance than heaters with combustion, for example. And a well-insulated, especially external insulation envelope is more, can I say, delicate, is more, it's more subjected to weathering condition, for example, than simple brick walls plastered. Okay, so what we have to face, what we will need to face, that even if we are able to implement renovation strategies at a high and widespread level, we should be able to foresee how this building have to be maintained. And at the moment, single owner maintenance is not sufficient. So we have to gather people together, to put people together, to create communities that they are in charge not only to work on energy production and consumption and so on, but also to manage and to preserve energy efficiency of a building. So I'm a bit late, 8 minutes late. Conclusion. What can I say? Well, I hope that I've given you a quick overview on the possible energy efficiency strategy, the features of the future energy efficiency strategies that need to be implemented at European level. The document we talked about is quite interesting. It's innovative, revolutionary in some points, for my opinion, especially when it talks about buildings from architectural point of view. It is something that very seldom was addressed in European documents. And but it has some critical points, still some critical points. For example, management is one of these. The conclusion is that when we talk about energy efficiency of buildings, the issue is very complicated. Buildings are strongly related to people's life. Buildings are the place where we spend most of our times. They can be workplaces or houses, it's not important. Working on them need to take into account that they cannot be seen only as energy machines. So the devices that have energy as input and then maybe comfort condition as output, or they transform energy in another way that is wasted. Well, actually, it doesn't work. We need to think that building has a lot of, working on building has a lot of boundaries that are technological boundaries. It's okay, but there are also economic boundaries. So, for example, we have to work with people that have no money. No one gives money, no banks give money to an industry that has no money to invest in energy efficiency, but if it's not productive. But we have to do this with low-income people. And social issues. And finally, architectural issues that, in my opinion, are one of the most expected. Buildings were built according to some rules, to some technologies that were representative of the state of the art at the moment when they were built. We cannot skip it. We cannot pretend not to take them into account. They're fundamental, especially when I work on buildings that, for example, historical buildings have are historical witnesses. So we cannot, we have to preserve the historical value. So it's it's various and quite complicated. I hope I gave you an overview on these issues. It's the end of my presentation. I cannot see the chat, so I ask for, so I try to stop sharing of my presentation, and I try to, okay, have a look at the chat.
Okay, thank you.
Are there any questions? Thank you, Luigi. Are there any questions?
There are some comments. Oh.
Comments, questions, or request of...
Not just thanks, but question or comment. There are a lot of thanks.
Thanks. Critics, please don't critic my English at the moment. I need practice, really. My God, I understand I'm very
always
can I say rusted.
always need practice.
I don't want to speak.
Not only you, not only you.
I just speak with my dog, as you can see, but she has some German Shepherd blood in her veins, so I think she's not very interested in speaking English.
It's possible to implement an energy model at district scale in GIS environment?
Yes, you will see maybe tomorrow, if I'm correct, a presentation from Stefano Pili. Is it tomorrow? I think it is. Yeah, tomorrow, where the theme, can I say, the issue of collect information regarding energy performance of building or building features can be addressed with the use of GIS environment. Yes, it is possible, and it is very useful. Going down on the scale, we can compare the BIM, so building information modeling, to a GIS, but at the scale of the only building. But the procedure and the aims are quite the same.
The very interesting perspective is to combine and join building model BIM in a GIS framework, so to construct, to create a CIM and city information modeling with all the information about energy of the single building at city level or neighborhood level. So this is the perspective that all the GIS platform like Esri are going towards. So this, I think, is the future.
Yes.
To have the information about the building, but about all the district, like in the BIM model.
Definitely.
Another, but why do you think public bodies are still resistant to implementing digitalization in ISO super detailed plans?
It's a good question. Well, I can confirm that there is a strong resistance. It's a cultural resistance because generally technicians that work on public bodies are, say, they work on emergency issues. They cannot work on future investments. So if, for example, the building needs maintenance, they're busy working on everyday maintenance issues. They need to stop a moment, and maybe they need to find financing to, can I say, put together the everyday needs to a future perspective, trying to convert one or two technicians in the role of digitalization of the buildings. that needs times. It's not easy. It can be automatized, but it needs work, knowledge, skills that have to be built. So it's a benefit in the future, but needs time and money investment at the present. So can I say they just stop a moment, understand that it is important, and try to create structures that can work on this.
Okay. Other questions? Comments? Not critical comments.
Oh, it's okay.
That's positive.
Can I make a question? Does anybody already know the document that I show from European Commission?
First answer is mine. No.
Okay.
Anybody? Anybody knows the document?
Wave.
Already knows this document, or was a surprise?
A renovation wave.
It's been a surprise. It's been a surprise, I think. Yeah. It's very recent, so I think nobody knows.
Yes. Do you want me to share it in some way? I can
In the
send
chat,
it,
if there is the link in the chat. There is another question. Why?
I can. Why? What does your wife be? Letting a dog outside if she's giving you sensible heating? Yes, she's giving me. Yes. But she wants to go outside. She needs to go outside, so I cannot. I cannot avoid.
Okay, I think you can share the if you have the link in the chat.
Okay. Allora, so chat type message here. Okay, new renovation wave strategy. Okay, it's uploading.
Okay, so if there are no more questions, thank you for sharing the link. I thanks Professor Desogus for his very interesting presentation.
It's been a pleasure.
Invite him as usual to stay with us during our co-working lab to give a look to the project the group are creating or working on. And so have a nice day, and see you for the digital lunch at 1 p.m. with Vanessa Castambroto and Daniele Giusto. So two other webinar, very interesting. So I'm waiting for you with the lunch in front of the screen.
From breakfast, from digital breakfast to digital lunch. Okay.
Yes, we have these 2 appointments every day, digital breakfast, digital lunch, and we have even the digital dinner because the co-working lab that finish at 8 usually. So we have the digital dinner too.
Okay, I have a meeting this evening at the same, more or less the same time. But if it ends early, I can
maybe tomorrow or tomorrow, when you can. You are welcome, of course.
Okay.
So thank you again.
It's been a pleasure. Thank you very much.
See you. Bye.
Bye.